We're picking up here with our exam review packet, starting with question 10. And we need to do a quick refresher on logarithms. We'll also be doing some problems with exponentials in these next two videos. So question 10 is the very definition of a logarithm. So what do we need to remember? Well, we need to remember that this value is the result. And students always mix that up with this value on the other side. And the secret here is to hear your teachers saying logarithms are exponents. A logarithm is equal to an exponent. So the answer to the logarithm is the exponent. And this number here, I think most students don't have trouble with. That's the base, and it makes sense because it's written a little bit lower. So what does this statement mean by definition? It means the base is A, the exponent is C, and the result that is produced is B. So we say that the logarithm of B in base A is C, because we need to put an exponent of C onto the base if we want to produce a result of B. So it looks like this is choice C in our multiple choice. Okay, so let's try this again. So in number 11, we know the base is 2, and we're looking for an exponent that we can put on that base so that the result is equal to 8. So once you practice logarithms, they're really so simple. So what exponent do we need here to change 2 into an 8? Clearly we want to cube it. So once you get used to the definition here, all you need to do is think in terms of exponents. When we don't have a base written and it's spelled L-O-G, then by default the base here is 10. So when it's spelled L-O-G, we don't bother writing the base. If we're using the most common one, our number system is in base 10. So here we're saying, what's the logarithm of 100 in base 10? So you say to yourself, what exponent do I have to put on 10 in order to turn it into 100? And clearly, we would like to square it. So it looks like I've got a mistake in the problem here, because the number 2 doesn't appear. So let's actually fix this one. Doesn't make too much sense, so we'll fix my typo. If I use this worksheet next year, we'll say that that's a 2. All right, well, what's changed here in the next one? In the next one, we haven't spelled it L-O-G, so this symbol, which is not the letter I, this is Ln for natural logarithm, and the natural logarithm has the base E, and E is a naturally occurring number. It is irrational. It continues infinitely. So when it's spelled Ln, we say natural logarithm. All right, which of these values is closest to E? You just saw me write E a minute ago, so we're going to circle this one and move on. So like you remember, pi is approximately, pi is not exactly 3.14. Pi is irrational, never terminates and never repeats. Likewise, E is an irrational number. So this is not the value of E, it's an approximation of E. All right, so simplify the natural logarithm of E. Well, let's remember here that when there's no base written, here, our base is E. So here we're saying E to what power produces E? It's almost too simple. That's just E to the first power produces a result of E. 16 says, what's the common log? Well, there's a terminology question. Common log is base 10. Natural log is base E. Common log is base 10. So we are saying the common log of 0.001, another way of writing that, tenths, hundredths, thousandths. So you might be able to see it more clearly here. What do we need to do? We raise it to the third power to turn it into 1,000, and then to do its reciprocal, we do a negative on the exponent. So remember that the negative part of an exponent is a reciprocal. All right, in 17, this might be easier for you if instead of 1 over e to the third, we flipped it over and wrote it as the natural log of e to the negative 3. So our base is e. What exponent on e produces e to the negative 3? Our answer's right there looking at us. The exponent must be negative 3. All right, back to some other bases. In number 18, our base is 27. So here we're saying, what do we have to do to 27 if we want to turn it into 1/9? Well, I kind of hope you recognize these are both base 3 numbers. So I hope you'd say, well, this, if I do its cube root, breaks it down to a 3. So if I do a cube root, that's a 1/3 power. And then I would square that to turn it into a 9. And then I would do a negative exponent to do the reciprocal. So I would like you to be able to look at this and say, I'm going to do a cube root, and then I'm going to square it, and then I'm going to flip it over. So I hope you could come up with negative 2/3. If you have trouble with these, though, of course, you can show some more algebra. You can write 27 as 3 to the third. You can write 1/9 as 3 to the negative 2. And then we're looking for what exponent we should put on the left side. What exponent should we put on the left side so that these two things would be equal? So power of a power, we multiply those exponents. And how could these two numbers be equal to each other if the bases are equal? Well, then the exponents must be equal. I think this keeps you from thinking through the exponents, though. So I would prefer when they're base 3 numbers that you just say step by step, what do I do with my exponents? All right, number 19 looks very complicated, but again, the trick here is that our base is the square root of 2a, and if you wish, remember, square root can be written as a 1/2 power. So there's our base, the square root of 2a, and our question is, what's the logarithm? So what's the exponent we should put on that base if we want to turn this into 16a to the 4th as our result? So you might be able to start thinking about what exponent you want to do here. So if we want to take the square root of 2, if we squared it first, so if we squared it, then we would be to 2a. And then once we're to 2a, then we would have to go to the 4th power. So if you think about this one step by step, squaring it first gets rid of the square root. And then if I raise it to the 4th power, do you see how that's going to turn that into a 16a to the 4th? So altogether we squared it and then we raised it to the 4th power. Power of a power, we actually raised that to the 8th. So we multiply exponents. There's lots of different ways you could think through these. You don't have to do them one step at a time. All right, we've got base of 32, and we want a result of, or we want an exponent of negative 2/5. So here, notice our variable is the result this time, and we're given the exponent. So what do we do? Well, remember the 3 parts of an exponent. The 1/5 power is the 1/5 root. So 2 times 2 times 2 times 2 times 2, 5 times is 32. So the 5th root of 32 is 2, and then we square it to get 4, and then the negative is the reciprocal. So I think we should have a 1/4. So again, I think that I have a typing error in my worksheet since I have a negative exponent. So let's think about this again, make sure I didn't say it incorrectly. The 5th root of 32 is 2. And then we want to square that to get 4. And then we want to do the negative 1. So we should have a 1/4. So one of these is a typing error, and it looks like that's my likeliest place for a typing error. So let's call that a 1/4. All right, in 21, for any value of x that is greater than 0, so we've got a base that is positive is what we're saying here. If our base is positive and we want a result of 1, so think of some number a, and we want to raise it to some exponent to produce the number 1. So Do you see that anything to the 0 power, we always say any number to the 0 power is equal to 1? Well, that's true, of course, if a is a positive number. So there's our a to the 0 power, or x to the 0 power produces 1. So as long as this x value is greater than 0. All right, in 22, how can we approach an equation that has its variables in the exponent? Well, the first thing to look for here is, are these two bases similar to each other? And indeed, they are both base 2 numbers. So we could rewrite this. If they did not have the same base, then we would have to use logarithms to solve this problem. But notice we can use our power properties. Power of a power, we would multiply these exponents together. We would multiply these two exponents together. And now do you see that if the bases are equal, then the exponents must be equal to each other? So we've got a pretty simple equation to solve here. If I can write it correctly, we have 10x and 15, sorry. So when we divide, 15 over 10 is 3/2. All right, I think we can get a couple more in here and then we'll move to another video. The logarithm of 10 divided by x. Now we're practicing our log properties. So remember that these are exponents when we're talking about logarithms. So remember what you do with exponents when you are dividing. Remember that we subtract exponents. So now you have to reverse your thinking. What should we do with log of a quotient? The log of a quotient is the difference of two logs. And if you can remember the relationship between your power properties, that will make your exponent or your logarithm properties easier to remember. So the log of a quotient is the difference of two logs. Here we've got the log of a power. So what's the analogy in our power properties? The analogy is when we have an exponent on an exponent, we multiply the exponents. So here a logarithm itself is an exponent, and now we have an exponent on an exponent. So we're going to multiply these two things together. So we can move that x down in front of that logarithm. So we say that the log of a power is the power times the logarithm. So sometimes we do this as a notebook way of reminding students. The exponent used to be up here, and now we're bringing it down and multiplying times the logarithm. So I should circle the right answers here. Oh, and I'm going back to 23 to circle an answer. I notice I didn't finish. What is the common log of 10? Well, if the base is 10, 10 to what power produces 10? That should be a 1. So sorry, I didn't finish question 23. All right, how many we got left here? The natural logarithm of the square root of e. So much easier if you remember that a square root can be written as the 1/2 power. And now here we've got the property we were just talking about. A power can come down in front. So we multiply the power times the natural log of e. And now what is the natural log of e? When the base is e, what exponent produces e? There's our identity property again. So this would just be 1/2 times 1. Okay, and in our next video, I see we've got a graph exponential, so we'll do that in a separate video.